The relationship between massive flooding events and mammoth extinctions during the Ice Age represents one of paleontology's most compelling, yet contentious theories. Recent research reveals that catastrophic floods with flows exceeding 20 million cubic meters per second swept across continents during mammoth extinction periods. These floods left behind extensive geological and paleontological evidence of water-related deaths. While the debate between gradual climate-driven extinction and catastrophic flood theories continues to divide scientists, mounting evidence from 2020 to 2025 supports something extraordinary. The geological record documents unprecedented flooding events coinciding with the final phases of mammoth populations. From Siberian bone beds containing over 8,000 mammoth remains swept there by current to North American sites where mammoth skeletons lie buried in flood deposits. These deposits sit 1,000 feet above modern river levels. These discoveries, combined with recent cosmic impact evidence, including the 2025 Louisiana crater find, paint a terrifying picture. We're looking at Earth system-scale catastrophes that fundamentally altered Ice Age ecosystems. The Missoula floods represent Earth's largest documented freshwater flood events. Peak discharges reached 20 million cubic meters per second. That's 13 times the flow of the Amazon River. These floods carved 30,000 square kilometers of landscape in the Pacific Northwest. They removed 210 cubic kilometers of sediment and created giant current ripples 35 feet tall with 300-foot wavelengths. Dating reveals these floods occurred between 20,000 and 13,000 years ago, with most activity after 19,000 years ago. This precisely overlaps the period of mammoth population decline. At least 25 to 100 separate flood events occurred, initially cycling every 55 years. But then something changed. The floods accelerated to 1 to 2 year intervals for the final events. Individual floods lasted days to weeks, releasing energy equivalent to 4,500 megatons of TNT per event. The Altai Mountains of Siberia experienced comparable devastation. The Chuya-Kurai glacial lakes released 600 cubic kilometers of water at peak discharges up to 10 million cubic meters per second. Russian researchers documented giant bars 300 meters above modern river levels. Ice-rafted boulders several meters in diameter. These Siberian floods occurred between 19,000 and 16,000 years ago, with major events around 12,000 to 9,000 BC. Additional megaflood events affected multiple continents simultaneously. The Lake Bonneville flood in Idaho achieved 1 million cubic meters per second discharge around 18,000 years ago. Lake Agassiz floods in Canada released multiple events exceeding 150,000 cubic meters per second. Recent research has identified catastrophic floods that carved the English Channel, and massive events in Tibet with discharges reaching 1.1 million cubic meters per second. Paleontological evidence from multiple continents reveals mammoth remains concentrated by catastrophic water events. Clear taphonomic signatures show flood transport and rapid burial. The most dramatic example is the Byodyalek River site in Yakutia, Siberia. Over 8,000 bones from at least 140 mammoths accumulated in a single location. The bones were apparently swept there by the current. The Berelek Mammoth Graveyard in the East Siberian Arctic contains thousands of disarticulated bones. These came from over 156 individual mammoths deposited in floodplain and Oxbow Lake sediments. Comprehensive 2024 research by Petulko revealed bone accumulation occurred during Loup Levy Lake formation. Alternating flooding-draining cycles happened between 13,700 and 11,800 years ago. The bones lie entombed in thick accumulations of gray-brownish silt characteristic of flood deposits. North American sites provide equally compelling evidence.
The Coyote Canyon Mammoth in Washington state was discovered within Missoula flood deposits.
It sat at 315 to 320 meter elevation, with a nearly complete skeleton articulated within 7 slackwater flood beds. These beds dated to 17,400 years ago. Ice-rafted erratic rocks intermixed with mammoth bones confirmed catastrophic flood transport. The Waco Mammoth National Monument in Texas preserves a nursery herd of 26 or more individuals. They died together in a single catastrophic flash flood or mudslide event around 67,000 years ago. Taphonomic analysis reveals specific water transport signatures. 135 rounded bone specimens at the Oyagos Yar site show varying degrees of water abrasion. Systematic disarticulation patterns indicate hydraulic sorting by bone size and density. Bones frequently exhibit vivianite coatings, iron phosphate minerals indicating burial in waterlogged and noxic conditions. The preservation of bone marrow and limb bones demonstrates rapid burial preventing decomposition. Articulated elements show minimal transport time before entombment. The Younger Dryas boundary cosmic impact hypothesis provides a potential trigger mechanism. These massive flooding events affected mammoth populations around 12,800 years ago. Recent breakthroughs include the 2025 discovery of the first confirmed impact crater in Louisiana. It measures 300 meters across with shocked quartz, melt glass, and impact markers. These are precisely dated to 12,835 to 12,735 years ago. Research at Abu Hurira, Syria, documented melt glass formation temperatures exceeding 2,200 degrees Celsius. That's far beyond any natural terrestrial process except cosmic impact. The glass contains melted quartz, carbon-infused plant imprints, and iron silicides, indicating extraterrestrial origins. Platinum group element anomalies appear at over 50 sites across 4 continents. The timing is synchronized within analytical error margins. The impact mechanism for triggering massive floods involves multiple pathways. Direct airburst effects over ice sheets could generate extreme heat and kinetic energy. This would cause structural failure of ice dams. Shock waves and seismic disruption could fracture glacial lake containment structures. Impact winter scenarios, followed by rapid warming phases, would destabilize ice through thermal shock. Massive dust injection and biomass burning would alter regional heat absorption patterns. Lake Agassiz's catastrophic drainage exemplifies impact-triggered flooding. It released approximately 21,000 cubic kilometers of water through the Mackenzie River system to the Arctic Ocean. Peak discharge reached 1.8 to 2.5 million cubic meters per second, sustained for 6 to 9 months. This freshwater pulse disrupted Atlantic meridional overturning circulation by 30% or greater. It triggered the Younger Dryas cooling period that lasted 1,200 years. The mammoth extinction debate remains deeply polarized between researchers. Some advocate catastrophic impact scenarios, others support gradual climate-driven decline. The controversy has intensified significantly in 2022 to 2024. Major publications and comprehensive rebuttals are appearing in high-impact journals. Proponents of the catastrophic Younger Dryas impact hypothesis include Richard Firestone from Lawrence Berkeley National Laboratory. James Kennett from UC Santa Barbara, and Alan West argue the cosmic impact evidence is reproducible. They point to nanodiamonds, microspherules, black mat layers, and recently claimed shocked quartz. These appear as definitive impact markers coinciding with megafaunal extinctions. Leading critics include Vance Holliday from University of Arizona and Todd Surovell from University of Wyoming. Philippe Claes from Free University of Brussels published a comprehensive 96,000-word refutation in Earth Science Reviews in 2023. They argue that most impact markers can be explained by terrestrial processes. They point to reproducibility failures and emphasize that extinctions weren't globally synchronous. Australian megafauna died 30,000 years earlier. South American extinctions occurred 400 or more years after North American ones. Gradual extinction advocates focus on climate envelope modeling and population genetics. David Nogues Bravo's pioneering research demonstrates something striking. 90% of mammoth geographical range disappeared between 42,000 and 6,000 years ago through climate-driven habitat loss. Recent 2024 genetic studies by DeHask analyzed 21 Siberian mammoth genomes. They found gradual accumulation of deleterious mutations over 6,000 years. This showed population bottlenecks, followed by recovery, but persistent genetic decline from inbreeding depression. The debate has become increasingly contentious. Accusations of pseudo-skepticism versus extraordinary claims rhetoric appear in peer-reviewed publications. Major methodological disputes center on radiocarbon dating interpretations, statistical methods for temporal correlation, and standards for evidence reproducibility remain contested. Major discoveries from 2020 to 2025 have provided unprecedented insights into mammoth-flood relationships. These include the world's largest mammoth bone concentration and perfectly preserved specimens in flood contexts. The Mexico City airport site, discovered in 2020, contains over 200 mammoth skeletons, plus 25 camels and 5 horses in an ancient lake bed. The animals were attracted and trapped in its marshy soil, with evidence of rapid burial in mud following natural deaths. The 2024-2025 discovery of Yana, a 50,000-year-old baby mammoth calf in Siberia's Batagaica crater, is extraordinary. It represents the best-preserved mammoth carcass globally. Found in thawing permafrost, the specimen retains internal organs in soft tissues. This provides unprecedented research opportunities for genetic and microbiological studies. The preservation quality confirms rapid burial in frozen storage, preventing decomposition. Abu Herrera melt glass analysis, published in Nature in 2020, documented formation temperatures exceeding 2,200 degrees Celsius. It contained iron silicides and native elements, indicating extraterrestrial origin. The low water content is consistent with cosmic impact glass. Plant imprints show instantaneous high-temperature melting. This represents the first direct physical evidence linking cosmic impact heating to Ice Age archaeological sites. The Louisiana crater discovery in 2025 marked a breakthrough for impact hypothesis proponents. Comprehensive analysis, including shocked quartz, melt glass, magnetic anomalies, and hydrocode modeling, confirms low-altitude airburst origin. Radiocarbon and argon-argon analyses precisely date the event to 12,835 to 12,735 years ago. This provides the first physical crater structure associated with the Younger Dryas boundary. Advanced dating techniques have refined flood chronologies with increasing precision. Optically stimulated luminescence dating provides precise flood timing. Cosmogenic isotope dating refines ice sheet retreat timing. Tephra correlation using Mount St. Helens volcanic ash layers provides chronological markers across the Pacific Northwest. The accumulated evidence supports a complex multi-causal extinction scenario. This isn't a simple catastrophic or gradual model. Massive flooding events clearly affected mammoth populations through habitat destruction. They eliminated migration corridors and caused direct mortality. But these operated within broader climate change contexts rather than as isolated catastrophes. Temporal correlations show critical overlap periods. Mammoth extinctions occurred 45,000 to 4,000 years ago, depending on species and location. Major megafloods concentrated between 20,000 and 13,000 years ago. Cosmic impact evidence appears precisely at 12,800 years ago. The Wrangel Island mammoth population survived until 4,000 years ago despite genetic bottlenecks. This indicates resilience where flood impacts were minimal. Geographic patterns reveal differential flood impacts across mammoth ranges. Siberian populations faced repeated glacial lake outburst floods and river avulsions in periglacial environments. North American populations experienced the most devastating megafloods from glacial dam failures. European populations dealt with smaller scale but still significant floodplain changes. Australian and South American megafaunal extinctions preceded major Northern Hemisphere flooding. This supports multiple extinction pathways. Environmental cascade effects likely amplified flood impacts beyond direct mortality. Widespread biomass burning eliminated food sources across thousands of square kilometers. Rapid temperature fluctuations exceeded adaptive capacity. Ecosystem disruption affected plant communities and food webs. Flood devastation destroyed traditional migration routes and feeding grounds. This isolated populations and created genetic bottlenecks. The Mammoth tsunami theory represents a compelling synthesis of geological, paleontological, and astronomical evidence. Catastrophic flooding was a significant factor in Ice Age extinctions. While scientific debate continues regarding primary causes and mechanisms, the evidence is overwhelming. Massive flood events coincided with mammoth population declines. They contributed to the environmental catastrophes that ended the Pleistocene epoch. The geologic record provides unambiguous evidence for flood events, 100 to 1,000 times larger than any modern catastrophe. Documented flows reached 20 million cubic meters per second during critical extinction periods. Paleontological evidence from multiple continents shows clear signatures of water transport. Concentration and rapid burial of mammoth remains is undeniable. Recent discoveries, including the Louisiana impact crater and Mexico City mammoth concentration, continue to strengthen the case. We're looking at catastrophic processes on a scale we can barely imagine. Rather than simple catastrophic versus gradual extinction models, the evidence points towards something more complex, a cascade of environmental changes where cosmic impacts potentially triggered massive floods. Combined with climate change and human pressures, these overwhelmed the adaptive capacity of mammoth populations. This multifactorial approach may ultimately reconcile competing theories. It acknowledges the dramatic scale of late Pleistocene environmental catastrophes. These fundamentally altered Earth's ecosystems and drove one of the most significant extinction events in recent geological history.